Good morning everyone. My name is Dr. Kunal Patel and in continuation with our machine learning journey, today we are going to see one another important regression algorithm that is known as the polynomial regression. Now first of all I'm going to cover some theory concepts, right? And after that we will cover the practical example. So let's first of all start with the basic definition. What is polynomial regression? So polynomial regression is a regression algorithm that models the relationship between dependent, that is y, and independent variable, that is we are knowing as x, as nth degree polynomial, right? So if you guys don't clear about dependent and independent variable, then you can see my previous videos. In that I have clearly explain what is the meaning of dependent and independent variables. Now here we are going to cover the nth degree polynomial. So let's start with the basic equation. So here is the polynomial regression equation, that is y is equals to b0 plus b1 x1 plus b2 x1 square plus b3 x1 cube up to bn x1 n. So here you can see guys, we have some coefficients b0, b1, b2, b3, right? Here there is a correction b3, okay? b3 x1 cube, okay? Now here let's go ahead and see what is the need for polynomial regression. So if we apply linear model on linear data set, right? So here we have two types of data set, where one is a linear data set, another one is the non-linear data set. So if we apply linear model, that is with the use of linear regression, then it provides us the good results. But if we apply the same model without any modification on non-linear data set, then it will produce the drastic change in the output. So here, due to which loss function will increase and the error rate will be high and accuracy also will be decreased. So for such cases where data points are arranged in a non-linear fashion, then we are going for polynomial regression model. So let's see the difference between simple linear model and polynomial linear model. So here you can see that this is our basic equation for linear model, that is y is equals to b0 plus b1 into x, right? And y is our dependent variable, x is our independent variable. And if you draw the line, these are the data points. These are the particular different data points we have. So these are data points are non-linear data points. So if you draw a simple linear model line, then the line will be like this. The line will be like this, right? So you can see we are missing, there are lots of information over here, right? So if you want to solve this kind of problem, then obviously you have to choose the polynomial model, right? So whenever your data points are not in a linear fashion, it is in a non-linear fashion, then you can go for the particular polynomial model. So here these are the data points we have, and here we have a polynomial regression line, right? So here what equation it fits, that y is equals to b0 plus b1 into x1 plus b2 into x1 square, right? So this is second nth, means second degree polynomial regression, right? N means a degree. Now here let's quickly revise our types of regression with equation. Suppose if you go for simple linear regression, then y is equals to b0 plus b1 into x. If you go for multiple, then b0 b1x, b2 x2, and b1 x1, b2 x2 up to bn xn. And for polynomial regression, if you go for, then b0 b1, b1x, x square, x cube up to xn, right? So this is guys for the theory purpose, okay? Now let's jump onto the particular example. So in that example we are going to solve one problem that is known as we are predicting the salary based on the positions, right? So here we have one CSV file. So if you open this particular CSV file, then we have position, then also we have a label 1 2 3 4 according to the position, and one salary structure, right? So this is one standard database. You will find this database on the internet or from the Kaggle site, right? So you can practice on it, guys. Now this is our database. Now I want to predict the equation with both linear and polynomial regression, so you will get the difference. So first of all, if we start that these are the basic libraries, you can import for that. Now we have a data set that is position salaries .csv file. Now we are fixing our independent and dependent variables. So this is my logic for machine learning. If you apply this logic, then it will fit for all the machine learning algorithms, that is templates. Now after executing that, if you see that x value will be like this 1 2 3, that is our labels, right? So with that position, according to the position labels are there, business analyst 1, junior consultant 2, like that. So you will find the x. Now if you print the y, then also, so this way you can check the particular values of x and y. Now let's train our model first with the basic linear model, so you can get the difference. So here from sklearn library, we are going to import the linear regression. We are creating the object and we are using the fit function. So I hope you know the meaning of fit function, guys, right? So actually here we are training our model, so x and y. Now we train our same model with the use of polynomial regression. So here we are going to import one class, that is polynomial features, right? And here again we are creating polynomial function. So here we have to apply the degree. So up to what degree you can solve this polynomial regression. So right now I have took the 4. So you will get what is the meaning of it. I will explain later on. Now here we are going to use the fit transform function. Okay, so obviously you will know the meaning of fit transform function. And after that we are again train our model with this transform x polynomial and the y's, right? So now let's see what is the difference between these two. So first of all, if we visualize the linear regression model and if we plot a graph, then these blue colors are points are our data set, right? So this is our linear model. So first of all, we are predicting the x value based on linear model. So here we have trained our model with this linear model. So we are first of all checking with it first with the linear model. So you can see that this line is passing over through this. So there are lots of points are missing over here, right? So you will not get the accuracy. Now the same thing if we plot with the polynomial regression, then you can see, guys, here what we are doing, model 2 is our polynomial regression and we are predicting the particular value with the use of fit transform function over here, right? And you can see actually it is covering all the points, right? Suppose if I change the degree over here, suppose if I take 2 degree over here, okay, right? And if I run the cell, okay, so it is running. So you can see that some of the points are missing, over here, guys, right? So this is the meaning of degree. Suppose if you change the degree, then you will get the accurate result. So you just need to change the degree, right? And you can get the particular polynomial regression line over here, right? So now let's again discuss the difference between linear and polynomial in the predictions, right? So suppose if I want to predict the salary for 6.5, so guys you can see over it is showing that 33,000, 3,30,000 something point over here is there, right? But actually what is the meaning of this? So here you can see 6 and 6.5, so nearly the 6.5 is between somewhere over here 15 to 1,50,000 to 2 lakh, right? So and here it is showing that it is 33, so it is a wrong value, it is not the accurate value, right? But if you predict the same value with the use of polynomial regression, guys, then you can see it is showing 50,000 1,58,000, so it is nearly between the 1,50,000 and 2 lakh, right? So it shows the accurate value, it shows the accurate value, right? So based on this you can also calculate the score values and coefficient values later on, right? But that is not our aim over here, but our aim is to predict the actual salary according to the basic position level, right? So you can see clearly over here in this video, guys, that this is predicted value with the use of linear and this is predicted value with the use of polynomial regression, right? So this is a wonderful example, guys. If you want to understand what is the meaning of polynomial regression and how it works, then this is a wonderful example. It is very easy example, guys, right? So I hope you like this video and you will get some information from this video for your future machine learning algorithms, right? So okay, take care, bye.